Hi guys, this is Erica. So for this discussion, I will be discussing one-way ANOVA. So my partner Carlo already discussed the ANOVA, the family of ANOVA. However, Turner only focused on one-way ANOVA. So in this discussion, we will be discussing the steps in calculating one-way ANOVA between groups and using ANOVA within statistical logic. So we have to remember these terms first. SSB, sum of squares between groups. SSW, sum of squares within groups. SST, sum of total squares. DF, difference between groups. DF within, difference within groups. MSB, mean of squares between groups. MSW, mean of squares within groups. K, number of groups. IV, independent variable, and DV, dependent variable. So this table already presents the values that are calculated from the data. However, as we discuss, you will know how we can get these values. Let's proceed. So this is the data. So in the data, as you can see, we have 12 students in each class, and we have 3 classes: the grammar-oriented class, the content-based class, and the email and internet class. So each have 12 students. So the first step, we have to calculate the SST, or the sum of total squares. Very good. So this is the formula for SST. So SST is equals to, summation of x squared minus open parenthesis summation of x close parenthesis squared over n. So the capital N again, it means total population. There. So when we substitute the values of the terms, we will have this. SST is equals to 252,044 or 252,044. So if we're going back to the formula, we have the summation x squared, and then we will be looking at the data. So we will see the summation of x squared is 252,044, this one, beside N36. There. And then we substituted the summation of x. Summation of x. So the summation of x here is this one. This is the summation of x. The 3004. Alright. And then we put the squared at the top, and then over n. N is the total population, and our total population is 36. So we calculated at equals to 252,044 minus 9,024,016 over 36. So we have the 252,044 minus 250,667.11 is equals to 1378.89. So you have to remember that the value of SST now is 1376.89. Now step 2. We have to calculate the SSP. So in calculating SSP, here is the formula. Do not be confused because those summation, these summations, the summation of x1, x2 at the lower part of the x is only the summation of each group. Yes, summation of each group. Don't you worry, you will be able to see the value of these summations in the table of your data. This one. So this one's for the x1, the 989, and for the summation of class, or yes, the class 2, or the second class and the third class. For the second class we have 101. For the third class we have the 1005. So we're just going to substitute this one. So we have these. So a while ago, we looked at our data table and we saw that the summation of x, or the first group, is 989, and then 1010, 1005. Okay, and then over, they are being divided by 12. Why 12? Because from the formula, it's small letter n. When we say small letter n, that is the population of the group. So each group has a population of 12 because each group has 12 students. Okay, so it is substituted there. And then you have to square each summation of the groups. Minus 2. Minus 2, the summation of x. Again, you have to square the summation of x minus n. So now we have this 3004 squared over 36 equals 2. So 989 is being squared. So 989 squared is 978 121. Next, 101 also is also being squared. So 101 squared is 10201000. So 1005 squared is 101025. And then they are being divided by their population or group population. Next, minus 9024016. So that's the square of 3004 over 36. So before we add the 978121 over 12 plus 10201000 over 12, we have to simplify them first. So we have to divide them to 12. Okay, so 978121 divided by 12 is 81510.08. 10 plus 10201000 divided by 12 is 85008.33 plus 101025 divided by 12 is 84168.75 minus 9024016 divided by 36 is 250667.11 equals 2. So we have to plus the 81510.08, 85008.33 plus 84168.75. So we will have 250687.16 or 16 minus 25067.11. So that's equals to 20.05 rather. So you have to remember that our SSB is the 20.05 or 20.05. Next step. So step 3, SSW. So to calculate the SSW, our formula is SSW is equals to SST minus SSB. So a while ago, we already calculated the SST and SSB. So the value for SST is 1376.89 and the value for SSB is 20.05. So we just have to substitute them. And then Our solution is SSW is equals to 1378.89 minus 20.05 or 20.05 is equals to 1356.84. So our SSW now is 1356.84. Next step, we have to calculate the degrees of freedom between and within groups. So our formula is DF means degrees of freedom. DF between is equals to K minus 1. Now, let us recall what do we mean when we have the term K? So when we have the K, it means that number of groups. How many groups do we have? We have 3 groups: the grammar-oriented, the content-based, and the email and internet class or group. So next, we have the formula for the degrees of freedom within groups rather. So DF within is equals to 9 minus K. So our solution is here, degrees of freedom between 3 minus 1. Again, why is it 3? It's because we only have 3 groups. So 3 minus 1 basic is equals to 2. Degrees of freedom within is equals to 9 minus K. 9 minus K, that's the formula. So their values are 36 and 3. So 36 minus 3 is equals to 33. So we have to remember that our degrees of freedom between is 2. And our degrees of freedom within is 33. Step 5. So we have to calculate the mean between and within groups. So if a while ago we calculated the sum, this time we will be calculating the mean between and within groups. So here's our formula. Our formula is MSB is equals to SSB. So MSB is mean. Once again, MSB, let us recall, MSB is mean between groups. Am I correct? Let's check. Yes, MSB, mean of squares between groups. So, there you go. Where are we? Here. So, MSB again is mean of squares between groups is equals to SSB over DF or the degrees of freedom between. For our MSW or the mean of squares within groups is MSW is equals to SSW over DF within. So when we have over, it means the operation is division. So here's our solution. A while ago, our SSB is 20.05 and our DF or our degrees between is 2. So our solution is MSB is equals to 20.05 divided by 2, and we have the answer 10.03. Now, for our MSW, we will just be substituting our SSW that is already calculated a while ago and our DF within. So our DF within is 33 and our SSW is 1356.84. So 1356.84 divided by 33 is equals to 41.12. This is MSW. Okay, MSW is equals to 41.12. Alright. So we already calculated this part, the sum of squares between groups, sum of squares within groups, and the total, the degrees of freedom, of course, between and within. Mean of squares, we already calculated that, and within groups. Later on, we will be discussing the F ratio and the significance. Now, we will now be discussing ANOVA or using ANOVA within statistical logic. So as we all know from the Turner's book, she followed 10 steps in statistical logic. So the first one, of course, we have to state the formal statistical logic. So we have to state our hypothesis. We have the null hypothesis or the HO, and the HA is the alternative hypothesis. So basically in this discussion, we will be looking for difference between the groups. Now, how our null hypothesis is there is no statistically significant difference in the mean knowledge of English among the participants receiving one of the three types of ESL instruction. And our alternative hypothesis is there is statistically significant difference in the mean knowledge of English among the participants receiving one of the three types of ESL instruction. That's the first step. So the second step is to set the alpha. So our alpha is 0.05. Next step, step 3. We have to select the appropriate statistic analysis of data. So in this manner, we will be using one-way ANOVA. However, for us to be sure that one-way ANOVA is the right tool for this data, we have to check the following first. Participants are randomly selected from normally distributed populations. So for you to use the one-way ANOVA, you have to make sure that your participants are randomly selected from normally distributed population. Next, your participants are randomly selected or assigned to one levels of the independent variable. Okay? Next, we have the IV. IV is nominal or the independent variable is nominal and has more than 2 levels. So it should be nominal and it should have more than 2 levels. DV or the dependent variable is interval in nature. And lastly, the researchers seek to identify if there is probably a difference among the groups defined by the independent variable. So if you are able to check all of these, definitely you will be using one-way ANOVA. Step 4. So we have to collect the data. So here is our data. Next, we have to verify the assumptions for the statistics are met. Okay, so we have to verify the assumptions for ANOVA first. So we have to know if the levels of IV or the independent variables contain exactly the same number of participants. Let's recall, do we have the same number of participants for the first group or the first class? Yes, because for the GO class, we have 12. For the CB class, we have 12. And for the ENI class, we also have 12. So let's check. Another check. DV is interval or interval-like continuous and scores are normally distributed in the population and groups. So the dependent variable is interval or interval-like. And the scores are normally distributed. So the scores are normally distributed. If we're going to look at the bell curve, probably yes, they are normally distributed because the scores are not scattered. Next, number 3, there is a minimum of 5 or 10 participants of the groups defined by the level of IV. So do we have 5 or more than 5? Yes, we have more than 5 because we have 12 participants. 12 participants in each class or in each group. So we already verified the assumptions for the statistic are met. So next step, we have to calculate the F ratio. So our F ratio is to 0.24. It should be 244. Sorry. So it should be 0.244. Because if you divide 10.03 over 41.12, you will get 0.2439. So we have to round it off. So you will have 0.244. So you can see here in the table, it's 0.244. Alright. Next, we have to determine the degrees of freedom for statistics and use DF and alpha to find the critical value for the statistics or calculate the exact probability. So we have two ways. We have using the critical value approach. Okay. Using the critical value approach and using exact probability. So why are we calculating this? We are calculating this for us to know if we're going to reject the alpha or if we're going to reject the null hypothesis and accept the alternative, or accept the null and reject the alternative hypothesis. So the value of this step, of the value that we will be calculating in these steps, will be used to determine if we're going to reject the null hypothesis and accept the alternative hypothesis or vice versa. Okay. So we have two ways, or we have to approach using the critical value and using the probability approach. So we have first the using critical value approach. So step 1, of course, we have to determine the DF, or the degrees of freedom. We already calculated that. So DF between is 2, DF within is 33. Next, we have to set the alpha. So as we all know, our alpha is 0.05. Very good. Step 3, get the critical value. Now, in getting the critical value, you have to search for the table for that. But I already provided it for you. So this is the critical values for F for the 0.05 significance level. So 0.05 is our alpha. So here we have in the yellow one horizontal. Am I right? Is it horizontal? Vertical? Whatever. This one, I already, labeled it. So we have the DF within and the DF between. The 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 at the above are the DF between. And the 1 to 35 at the left side of the table, that is DF within. So our DF between is what? Let's circle again. Our DF between is 2. Very good. And our DF within is 33. Alright. So we have to look first for the column 2. That's 2. And the row 33. So we will see the value of it. We have 3.29, or if we're going to round it off, it will be 3.30. So that is our critical value. Next, using the exact probability approach. So in the exact probability approach, I did not give you the calculations using calculator, because Turner gave the command in the R program. However, we're not using the R program because our teacher suggested us to use SPSS. But, SPSS is friendly user. Yes, is that the right term? Yeah. There you go. So the F is 0.244. We already calculated that. And the P value, okay, is 0.785 according to Turner. According to her calculations. Okay. Next, we have to interpret the outcome of the analysis, compare the observed value and the critical value, or compare exact probability to alpha. So, in this step, we will now know if we're going to reject the hypothesis or accept it. So, we have the rules for comparing. Okay, the F observed and the F critical. So, if F observed is less than F critical, accept the null. If F observed is greater than critical, reject the null. So, if F observed is less than, accept null. If F observed greater F critical, reject null. So F observed is also this one 0.244. So F observed. So when F observed and F critical are compared, we see 0.244 is less than 3.30. So 3.30 is greater than 2.244. So from our rules, if F observed is less than critical, we have to accept the null. So that's it. In this step, we know that we have to accept the null. Now let's see if using the probability approach we'll have the same result. So the HO is accepted. There. Step 8, using the exact probability approach. So rules for comparing the exact level of probability for F observed to alpha are this one. If exact probability or the p-value a while ago is greater than alpha, we have to accept the null and reject the alternative. If exact probability is less than alpha, we have to reject the null and accept the alternative hypothesis. Let us recall our value for exact probability for the p-value. So we have 0.785 and our alpha is 0.05. So you write it down, 0.785 blank 0.05. Which one is greater? Very good. It is the p-value or the 0.785. So if exact probability is greater than alpha, it means we have to accept the null hypothesis. So they have the same result. Using critical approach and using probability approach. Next, we have to interpret the findings. So there is 95% certainty that there is no statistically significant difference in the mean knowledge of English among the participants receiving one of the three types of ESL instruction. So here when you interpret the findings, you are telling or you are already concluding that there is 95%, and it is 95% because we use the alpha 0.05, which is also equivalent to 5%. Now, if you're going to observe the words, they have almost the same word with the hypothesis. You just have to add the percentage. How many percentage? 95? Is it 95? Is it 99.9? And so on and so forth. However, just like what she said, since the research is exploratory, we have to use 0.05. Okay, and last step is we have to interpret the meaningfulness of the findings. So when we interpret the meaningfulness of the findings, I did not include it here, but it's written in our written report. When we interpret the meaningfulness of the findings, we are including the values that we calculated a while ago, how we come up that we rejected the null hypothesis or accepted the null hypothesis rather and rejected the alternative. So we have to state those. So that's how we interpret the meaningfulness of the findings. So that would be all. If you have further questions, you can PM me online, you can email me. You know my email because I already shared to you this PowerPoint presentation. So keep safe everybody and thank you so much.